Yes, dear students of ninth standard, now we are going to discuss about matter around us, which is Unit 10 in your science book, which is a chemistry portion. And early in the previous class, we learned about matter around us up to elements, the classification of elements. The further portion we are going to discuss now. Before we are going to discuss, I am going to check your knowledge, what you have acquired in the previous class. And the first one is define matter, or what is called matter. That you know very well, and already you have learned in 8th standard also. Matter is anything that has mass and occupies space. Matter is anything that has mass and occupies space. And there are three types of matter, solid, liquid, and gases. Then the classification of matter with regards to chemical composition we are discussing now. So based on physical, already we have discussed in the 8th standard. Now classification of matter on the basis of chemical composition. And matter is classified into two types: pure substances and impure substances. Pure substances further classified into elements and compounds, and impure substances are classified into homogeneous mixture and heterogeneous mixture. And is air a pure substance or mixture? Air is a mixture because air constitutes nitrogen, oxygen, carbon dioxide, water vapor, and dust particle. All these are the components of air. Also brass, which is a mixture because brass is a constituent of 30% of zinc and 70% of copper. Now, what is called an element? And there are 118 elements in the modern periodic table. A modern periodic table constitutes 118 elements. Out of 118 elements, 92 elements are naturally occurred and 26 elements are artificially prepared. From these 118 elements, we are getting millions and millions of compounds, and also artificially we are preparing many compounds in the laboratory. Now, I will be going to define element. So, element is a simplest form that contain only one kind of atom. That is called normally element. Also, what is an atom? What is called a molecule? Atom is smallest particle which take part in chemical reaction that cannot exist free in nature. But molecules are simplest particle that can exist independently, and molecules combine to form a matter. Then elements are further classified into metal, metalloid, and non-metal. Metal example copper, chromium, gold, aluminium, and metalloid boron, germanium. Non-metal carbon, sulfur, phosphorus, like that. Now we are going to study about compounds. So what are called compounds? So compounds are nothing but the combination of two or more elements. So two or more elements combine to form a new substance. In the element, only one type of simplest substance is there. That is only one kind of atom. So element is nothing but it contains only one kind of atom. But compounds are obtained by the combination of more than one kind of atom. So it is given, say, when two or more elements combine chemically to form a new substance, the new substance is called compound. So that is a given definition in your text. When two or more elements combine chemically to form a new substance, that new substance is called compound. For example, cane sugar. The formula of cane sugar is C12H22O11. So in this chemical formula, 12 carbon atom, 22 hydrogen atom, 11 oxygen atoms are there. So three different atoms chemically combine to form a molecule of cane sugar. And a compound has the properties that are entirely different from the constituent elements. So carbon is a non-metal, hydrogen is a gas, oxygen is a gas, but the cane sugar formula of C12H22O11 is completely different from the properties of the constituent elements of carbon, hydrogen and oxygen. Similarly, you can take example of common salt. So common salt which we use in our kitchen, which is called sodium chloride. Sodium chloride formula NaCl. Na sodium, Cl chlorine. So there are two components in sodium chloride, sodium and chlorine. Sodium is a metal and chlorine is a non-metal. Sodium is a metal. Sodium that have the property of reacting vigorously with water, violently with water. But non-metal, which is a chlorine, which is a poisonous one. But these two are combined to form a sodium chloride, which is a stable compound, which we use in our kitchen, which is entirely different from the property of the constituent element. And also see in the activity 2 it is given how to prepare models, a molecule of compound by using matchstick. For example, water molecule. What is the formula of water? H2O. In H2O, 2 hydrogen atom, 1 oxygen atom. In this structure, the water molecule is given. Similarly, carbon dioxide, CO2. Carbon dioxide formula CO2, 1 carbon, 2 oxygen, CO2. Similarly, you can prepare like a methane. Methane formula CH4. CH4. So the carbon is at the middle and 4 hydrogen, all the 4 sides is going to occupy. Using the matchstick, you can prepare the structure model of the methane. Also hydrogen chloride, HCl, hydrogen chlorine, sodium chloride, NaCl. So you can prepare the molecular structure using the matchstick. Next, see the do you know part. Compounds of phosphorus, nitrogen, potassium are used as fertilizer, which normally we used to say complex. See, the farmers use a complex for the growth and yield of the plants. See, the complex constitute phosphorus, nitrogen, potassium. Phosphorus P, the symbol of phosphorus P, nitrogen N, potassium K. You would have seen that in the packet of complex, it is given NPK. NPK complex with a different ratio, 17:17:17, and there are different ratio also given. But You would have seen that NPK complex. NPK complex means the mixture of nitrogen, phosphorus, potassium, which is used as in the fertilizer. Then also says silicon compounds are of immense importance in the computer industry, in the electronic devices. They used in the form of chips. And also see the compounds of fluorine, which is used in toothpaste to give more strength to our teeth. Then next see the difference between elements and compounds. So I already told elements are nothing but elements are made up of only one kind of atom. Elements are made up of only one kind of atom. But at the same time, compounds are obtained with a combination of more than one kind of atom. And element is a smallest particle, the very very smallest particle. Not only we used to call it as a atom, but molecule is the compound is smallest particle, but it retain all the properties in the molecule. Then element cannot be broken down into simpler substance, but the compound can be broken down using some chemical methods. The next to see mixture. A mixture is an impure substance. Mixture is an impure substance because a mixture going to constitute more than one kind of element or compound. They are going to be physically mixed together. Physically mixed, not chemically combined, physically mixed. So you can note down the definition of mixture. A mixture is nothing but it contains two or more kinds of elements or compounds are both physically mixed in any ratio, not in definite ratio. You have to understand, see, two or more different kinds of elements or compounds. So in the mixture, two or more different kinds of elements or mixtures are there, and these elements or mixtures are physically mixed in any ratio. They are not chemically mixed, and they are not in definite proportion or definite ratio, physically mixed and in any ratio. So these are the things you have to understand. Two or more different kinds of elements physically mixed and in different ratio, which is called mixture. For example, take tap water, water from the well or water from the tap, water from the ground, which is a mixture of some dissolved salts. For example, see the tap water constitute a calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate. These dissolved salts are there in the tap water or ground water. Similarly, in the lemonade, which is a mixture of lemon juice, sugar and water, and air. Already we learned air is a mixture because it constitute nitrogen, oxygen, carbon dioxide, rare gases, water vapor, dust particle. All these are in the mixture of air. And next to see soil, which is a mixture of clay, sand, and there's some dissolved salts are there in soil. Milk, similarly, milk contain cream, fatty substance, sugar. Ice cream also contain fatty rock salt, sodium, potassium chloride. Smoke, which is mixture of solid and gas. Wood, cellulose with some other element. And sea water, sodium, potassium chloride. Blood, which contains plasma, platelets, and RBC, WBC, and toothpaste, which contain fluorine with some other components, and paint, which contain oil, dyes. So all these are a combination and of different components in different ratio, not in fixed ratio. They are physically mixed. They are physically mixed, different component, and in not definite ratio. So they are called as mixtures. So they are called as mixtures. So you have to understand, mixtures are nothing but mixtures are the substance obtained from the combination of two or more different kinds of elements or compounds. And second point, and mixtures are physically combined. And third point, mixtures are not, the components of the mixtures are not in fixed ratio. So these are the three important points you have to note down in the mixture. Next to see, the more to know, it is given LPG. Already you have learned the LPG is nothing but it is a short form of liquefied petroleum gas. So the gas, the petroleum gas is obtained by the from the crude oil, and the crude oil is going to be heated. The vapors of crude oil is obtained. The vapors of crude oil is going to be condensed because it is a volatile one. It is going to be condensed and the gas is obtained. The gas, which is going to be compressed by applying pressure and turned to gas into liquid. The liquid form of gas is filled in the cylinders and supplied for the consumer purpose. So this LPG, liquefied petroleum gas, constitute mainly two elements, propane and butane. These are the two hydrocarbon, butane and propane. These are the hydrocarbon. These hydrocarbons are the main elements in the liquefied petroleum gas, which we are using for the heating and cooking, also in the car, vehicle as auto fuel. Then differences between mixture and compound. Differences between mixture and compound. Then see, in the activity 3 it is given, see, take some powdered iron fillings and mix it with the sulfur. Iron fillings, which is a dark gray in color, iron fillings, and sulfur is a yellow color powder. Sulfur, which is a non-metal yellow color powder, and iron filling, ions are metal. Iron is a metal, sulfur is non-metal. When we are going to mix these two will not going to combine chemically. They are going to be physically mixed. We are going to mix and we are taking into divide into two portions, and one portion constitute the combination of iron powder and sulfur powder. Iron powder and sulfur powder. And the other portion we are taking separately. So in the first portion, the combination of iron powder and sulfur powder, when you are going to bring the magnet, what will happen? The magnet going to attract the iron powder easily. We can separate iron powder from the mixture of iron and sulfur because these two are physically mixed, not chemically combined. But at the same time, the second portion, which is a constituent of iron powder and sulfur powder, when you are going to heat it in a test tube, what will happen? These two are going to chemically combine. Iron, Fe, sulfur, S. So this Fe plus S on heating give FeS, iron sulfide, iron 2 sulfide. So a chemical compound is formed on heating the iron powder with the sulfur powder. So this chemical compound cannot be separated using the magnet. Now when you are going to bring the magnet to the iron sulfide compound, the iron particle cannot be separated from the iron sulfide because these two are chemically combined. So the chemically combined elements cannot be easily separated using the physical method. The magnet, bringing magnet to the iron sulfide, that is a physical method. Using physical method, you cannot easily separate iron from the iron sulfide. Then see, it is given some descriptions about iron and sulfur powder. Iron, which is an element, which is a metal, which is a dark gray color powder, which is going to be attracted with the magnet. Sulfur, which is a non-metal, which is an element and which is yellow color powder, and there will be no attraction with the magnet. And when you are going to mix iron and sulfur physically, a dirty yellow color powder is formed, When going to bring the magnet to this dirty powder, iron powder can be easily attracted. We can separate using the magnet by using a physical method. Iron powder can be separated from the mixture of iron and sulfur. And the next one, see, iron sulfide. So this is formed by the heating of iron with the sulfur. When you're going to heat iron powder with sulfur, on heating what happens? See, iron sulfide, FeS, a black color solid substance is formed. Now when you bring the magnet, there will be no attraction of iron particles by the magnet, no effect. So from the above experiment we have to understand the major differences between iron powder and sulfur powder. Iron and sulfur, or we can understand what are the differences between mixture and compound. Now see in the do you know part it is given blood is a mixture. Already it is given blood is a mixture. Blood is not a pure substance. Pure substance means that should constitute only one kind of element. That is a pure substance. Blood is not constitute only one kind of element. Blood is a constituent of components like platelets, red blood cell, white blood cell, and plasma. So these are the constituents of the blood. So blood is not a pure one. It is a mixture of these components. Then differences between mixture and compound. So mixture, it contains two or more substances, but compound, it is single substance. The constituent may be present in any proportion. So mixture, there is no definite proportion of the combination, but in compound the elements are combined some fixed ratio, some definite proportion by mass. Then mixture, they show the properties of the individual constituent. The individual properties are going to be existed in the mixture, but in compound the component will not show their individual property. Entirely different properties going to be obtained. Then mixture, the components may be separated easily by physical method. Physical method like bringing magnet and using filtration method. So this method can be used to separate the components of mixture. But in compound, like this physical method by bringing magnet, using filtration, so this method cannot be used to separate the components of compound. So compounds cannot be easily separated, but some chemical methods, chemical reaction can be applied to separate the components of compound. Then activity 4, it is given, see, identify whether the given substance is a mixture or compound and justify your answer. So you have to check, you have to classify the given 9 compounds. There are 9 substances are given. You have to separate which is a mixture, which is a compound, by checking the type of substance. For example, take sand and water. Sand and water. So in the sand and water, the sand can be easily separated from water. We can separate sand from water using the filtration method, using physical method. So it is a mixture. And say sand and iron fillings. Sand and iron fillings. So sand and iron fillings also, it is a mixture. It is a mixture. When you are going to take sand, it is a silicon dioxide. It is a silicon dioxide and iron, Fe. But when they are going to be physically mixed, you can easily separate using the magnet. Using the magnet, you can separate iron fillings from sand. So that is a mixture. Third one is concrete. Concrete that you have seen during the construction of building, the concretes are used. How concrete is prepared? Concrete is prepared using cement, stone, water, and lime like substances. So it is also a mixture. So that machine itself called a mixture machine. That you have seen. That machine is called a mixture machine. The mixture machine, the workers going to take sand, water, cement, stone, all these are added and it's going to be rotated. The result, what you are going to get, that is called a concrete. So, which is a mixture. Then, water and oil. Water and oil, these two cannot easily, will not going to combine with one another. So, water is separately, when you're going to take water, it is a compound. But when water mixed with oil, it's going to form a heterogeneous mixture, but water will not dissolve. It's going to be easily, it can be separated using the separating funnel. So it is a mixture. Then salads are prepared, using fruits or vegetables. Salads are prepared. It constitutes more than one kind of element. So there is no chemical combination between the substances present in this salad. So it is a mixture. Then water. Sixth one, water. What is the formula of water? H2O. In the H2O, two hydrogen atom, one oxygen atom. So water, in water molecule, hydrogen and oxygens are combined in definite proportion by mass. You know the formula of water, H2O, two hydrogen atom, one oxygen atom. Two hydrogen atom, one oxygen atom. And atomic mass of hydrogen is 1. But two atoms are there, so 2 into 1, 2. Oxygen atomic mass 16. So actually the ratio of 2 is to 18. When you are going to simplify 2 is to 18, you will get 1 is to 8. 1 is to 8. So 1 is to 8 is the simple ratio of a combination of hydrogen and oxygen. Hydrogen and oxygen in the water molecule. So water is formed by the combination of hydrogen and oxygen in the fixed ratio by mass of 1 is to 8. So water is a compound. Water is a compound. Then next, carbon dioxide. Carbon dioxide formula, you know, that CO2. CO2. That is one carbon atom, two oxygen atom. One carbon atom, two oxygen atom. Carbon and oxygen, these two elements are combined in fixed ratio by mass in carbon dioxide. What is the fixed ratio? That is 3 is to 8. The carbon atomic mass is 12 and the oxygen is 16. 2 oxygen is there, so 2 into 16, 32. Actually 12 is to 32 will come. When you are going to simplify, you will get 3 is to 8. So the combination of carbon and oxygen in carbon dioxide molecule is the ratio of 3 is to 8. So it is a fixed ratio, it is a definite proportion. So compounds are formed only by the combination of element by definite proportion by mass. So in carbon dioxide, carbon and oxygens are combined in fixed ratio by mass. So carbon dioxide is a compound. Then you take cement. Cement is a mixture of cement is obtained. Cement going to constitute lime and ash. So it is a mixture. It is a combination of different kinds of element. So it is a mixture. Then take ninth one, that is alcohol. There are different types of alcohol that you are going to study about alcohol and types of alcohol in the next year, 10th standard. But alcohol generally going to constitute one hydroxyl group. Hydroxyl means OH. OH group with one alkyl group. Maybe C2H5OH, CH3OH, maybe ethyl alcohol or methyl alcohol, also called ethanol and methanol. So these elements constitute carbon, nitrogen, oxygen. So these elements are present in fixed proportion by mass. So alcohol is a compound. So out of these 9 given substances, water is a compound, carbon dioxide is a compound, and alcohol is compound. All the remainings are mixtures. The next to see types of mixture. See, most of the substances that we use in our daily life are mixtures, and some we will be able to see the components with our naked eye, but in most others the different components are not visible. So based on this, mixture can be classified into broadly into two types, that is homogeneous mixture, heterogeneous mixture. homogeneous mixture, heterogeneous mixture. Homogeneous further classified into true solution and alloys. True solution and alloys. Heterogeneous mixture further classified into two types: suspension and colloids. Suspension and colloids. So what is called a homogeneous mixture? So in the homogeneous mixture, the components cannot be easily seen through our naked eye. We cannot easily see the component. It is called a homogeneous mixture, a mixture in which components cannot be seen. That is called a homogeneous mixture. Then, because it has a uniform composition, the composition is uniform, we cannot easily separate the components of a homogeneous mixture easily. For example, tap water, milk, air, ice cream, sugar syrup, ink, steel, bronze, salt solution, they are all the example of homogeneous mixture. For example, you take tap water. Tap water is a mixture. Tap water is a mixture because it contains some dissolved salt, but we cannot see the dissolved salt easily in our through our naked eye. When you are going to take water in the glass tumbler, you cannot see any substances in the water. You are going to see water, it is going to be like a pure water, but it constitutes some dissolved salt. And we cannot, similarly, milk, ice cream, we cannot easily see, we cannot easily separate. So they are all called a homogeneous mixture. And a mixture with the components that can be easily separated, that can be easily seen through our naked eye, that is called a heterogeneous mixture. When you are going to see simply our naked eye, we can observe there are two separate phases are there. So it is called a heterogeneous mixture. So the elements are not constituted the uniform composition in the heterogeneous mixture. So in the elements are not in the uniform composition. For example, soil, which is a mixture of iodine, common salt. Soil, a mixture of iodine and common salt. And also see a mixture of sugar and sand. You can easily see the sugar from sand through our naked eye. And mixture of oil and water. When you take oil and water in a test tube, you can see that oils are going to be separately seen on the top of the water. That can be easily separated. Then mixture of sulfur and iron powder. So when you are going to mix iron powder and sulfur, you can see that iron fillings easily, and you can separate also easily through using the magnet. The mixture of milk and cereals. When you are going to add cereals with the milk, you can easily see and easily separate using the filtration method. So these are all the example for a heterogeneous mixture. So there are two types of mixtures broadly classified into two types: homogeneous mixture, heterogeneous mixture. Homogeneous mixture components can be, in the homogeneous mixture components cannot be easily seen and cannot be easily separated. Example, tap water, milk. And heterogeneous mixture component can be easily seen through our naked eye and also easily separated using physical method. And examples are seen. And so the next topic is a separation of mixtures. So this topic, the separation of mixtures and the methods of separating the components of mixture, that we are going to discuss in the next class. So we have to see the topics what we have learned now. See, compound. The compound is nothing but the combination of elements to give a new substance. The combination of two or more elements to give a new substance. Example, cane sugar, sodium chloride. And the differences between element and compound. Element is a simplest substance which consists only one kind, but compound contain more than one kind of atom. And mixture, which is a combination of two or more kinds of elements or compound, physical combination, and there is no definite ratio. And Next, see the difference between compound and mixture. Then, and the mixture of iron and sulfur, also compound of iron and sulfur, iron sulfide. Then types of mixture, that is homogeneous, heterogeneous. And homogeneous means that components cannot be easily seen through our naked eye. Example, that solution of sodium chloride, tap water. And heterogeneous mixtures, the components can be easily seen through our naked eye and easily separated using the physical method. Example, the mixture of sulfur powder, iron powder, mixture of milk and cereal. So dear student, you have to go through up to this and also note down all this in your classwork. Note down all this in your classwork, and don't waste the time. Revise the portion, that is matter around us, from the beginning up to this separation of mixture. You have to revise and prepare well. I wish you all the best. We will see in the next class.